Well, look what we have here. We found a vector calculus book with differential forms, and I am dying to see what kind of differential calculus we're gonna be doing in here. That's gonna be crazy. Let's look at this table of contents. We've got set theories, cool, complex numbers, looking at matrices, Newton's method, okay, for approximations of solutions and stuff, kernels and images. Oh my God, it's like cohomology theory there. We've got manifolds, Taylor polynomials, curvature, wow, tangent spaces across the manifold, dude, this is tight. Lagrange multipliers, pretty interesting stuff here. Probabilities and centers of gravity. Okay, that might be interesting. 417. I gotta go take a look at that or something. Volumes and determinants, Lebesgue integrals, parameterizations, that's really important. Fractals, wow, cool. Forms on R to the N, orientation of manifolds, the gradient, the curl, and the div. Wow, the pullback. I wonder if this is like trading stocks or something. Anyway, so let's see what kind of cool math we are going to encounter. Proving convergences, okay. Some different shapes and stuff. It's interesting here. Let's see. Get some cool problems. Some nice pictures. Good stuff in here. Differentiability and pathological functions. All right. Nice. The Jacobian matrices. Interesting. Orthogonal matrices. Orthonormal bases. Let's see what kind of stuff it is. So, orthonormal basis of R to the N. I think any vector should be able to be written as like a different orthonormal basis, so you can kind of switch around to the different bases you want to describe your vector in. And then let's keep going here. So there's some other things. Newton's method. It's kind of cool. So those. Let's see what else we can find in this crazy book. Manifolds are independent of coordinates. What is this? A curve in space. So we like to be able to parameterize things because I think sometimes, you know, if they're not continuous, then you can maybe parameterize things and make it more of a continuous derivation. Might be possible. Something we were doing in our live sessions. Computing the curvature of the plane curve. The second derivative divided by the first derivative squared plus 1 power there. It's interesting. And what else can we do? Oh, there's little sticky pages here. Matrices and determinants, cylindrical coordinates, spherical coordinates. And then I guess, what else could we be looking at here? Let's see what kind of crazy things they had that might have been interesting chapters to take a look at. For example, probabilities and center of gravity, 417. Just go check that out and see what that's all about. What's there? So, 417, probabilities and the centers of gravity. Then computing areas and volumes. And the center of gravity, oh, okay. So maybe, so I think the center of gravity is just like the normal center of gravity, like would be here. But what is this whole thing? Probability. The density of probability. Center of gravity and probability integration. Assigning numbers to events. And coming up with probability density, Buffon's needle. This is some crazy stuff, but essentially, like, you know, if you really want to get into the vector calculus, as you can see, we're doing a proof of the chain rule here. It's kind of cool. What else do we have? Proof of lemmas. Oh, are these just a whole bunch of proofs in the back? Oh, cool. We got a whole bunch of proofs in the back here. Boundary orientation. We're trying to find the bridge through the cut edge of a Koch snowflake. What? Oh, this is cool. A little spiral region. But yeah, I think over here they got grad, the div, and the curl. So this is pretty cool. Pullbacks, Riemann sums. So they just have a whole bunch of proofs, I think, in the back here. So arithmetic real number. There you go. Really cool things. Taylor polynomials, chain rules, proving propositions. Well, anyway, this is definitely some really hard math. If you guys want to check out this book, it's looks pretty good. It's the Vector Calculus, Linear Algebra, and Differential Forms, 5th edition by John Hubbard and Barbara Burke. Thanks for watching, guys. Have fun.